because at 3 p.m. today I got postgraduate open days, which is I need to attend as the representation as a representative of our School of Computing. Okay, siapa yang baru nak join? Okay, before we start, yesterday, the person in charge who marked question 3 for your test 2 informed us that there is student upload the question to one website. The thing is, I already remind all of you don't do similar mistake like your senior did. But still, I don't know. I hope that it is not coming from section 3, section 9, and section 6. Because what I been mentioned, the student discussing about the question, and it is cross section. It is not like, okay, all from one section. No, it is not all from one section. It is cross section. Means that there is like over here maybe Ali, and then maybe Abu here. Different section, but they are discussing with each other. Why we know that? We not just speaking a lecture like 6 months, 12 months. We have a lot of experience dealing with this kind of problem. That's why I always remind all of you, don't do similar mistake like your senior did. And that is a very silly mistake. I don't think that it is mistake, because mistake is something that you did but with not in purpose, I guess. Something that you did but it is not a wrong thing. But when you did a wrong thing, you know already it is wrong. So why you did why you repeat again? Because you already about like week 10. I forgot about the weeks. You want to repeat the whole weeks that you have been through. You want to repeat your test 1. You want to repeat your lab 1, digital subject, because you copy each other. Or because you don't know the question. Maybe you don't know maybe one question only, but maybe it took about 50% of your marks. But if you don't know, maybe if you can try answer, maybe you can, okay lah, you just get 5%. But if you compare 50%, you need to repeat all. It is what we can say, it is insane because you want to repeat. This is a mistake that someone already been told you, don't do this, don't do that, but you did again. And this one person, I guess, if you can say, it can be like a prime minister, because everyone want to follow him. I don't know, maybe if this person asks, can I go out with your girlfriend? Maybe this person also, okay, go. I allow you to go out with my girlfriend because I believe you. This is the things that I said, don't depend with others. You depend with your leader. Okay, your leader will submit your video, your leader will submit your lab sheet. Don't do this. Similar also, you don't know the question number 3, let's say, but you follow someone because this. Maybe you say, oh, I don't believe him, but I don't have choice. It still means believe. So you believe this one person, you also will repeat this digital logic subject. Okay, how we know? Maybe you said, how does the lecturer know I did follow or I did discuss? We know it. Okay, and one of the student maybe thinks, okay, when I upload to the website, I pay to the expert. They call expert, but they give you wrong answer, and you copy every single wrong answer. So who are the moron here? You want to be that kind of person? Don't lah, jangan jadi macam ni. I don't know what, because we are really like frustrated. Still, there is student repeat similar things. Why you want to cheat in your test? This is just a test. It is not even final exam, but I don't think that if you repeat this similar thing, I believe you're going to do similar to your final exam. And maybe I can give you a hint. There is one student that do like this. This is your care map, and these students are drawing like this. And maybe I just give a hint.
Doctor,
Yes.
do you share the screen?
Yeah.
No?
I did share.
Yeah,
Dia
don't
tak
have.
conteng dekat sini ha.
No, doctor, we don't see any screens.
Okay. So there is one student, maybe the person draw the care map like this. This is the given by the expert. So the student follow. One student follow. And then they say, okay, this is expert. This must be correct. But we never teach you like this. Whoever did this, whoever follow your leader to do this, you wait for us. Maybe you're going to get 0 for your test 2, or maybe you're going to repeat your digital logic subject. We're going to discuss about this matter because we don't want to repeat. Last time we give your senior chance. It happened to test 2, but they repeat. Although we already give warning, they repeat again. I think last time they get 0 for test 2, but they repeat again for final exam. They need to repeat because they repeat to copy paste, and then they repeat publish the question to the website last time. So we give them, because they like to repeat, right? So we give them to repeat the digital logic subject. Now, do you want to repeat your senior things? So if you want to repeat, then we can give you repeat also for digital logic subject. Do it. We give you directly repeat. This one, we already find out several students who did the question, who did the answer similar. You can justify whether you copy or not, but believe me, when the justification date, you cannot answer. Sometimes we like just keep quiet because there is no things you can defend. So just wait and see who did this. I hope that it is not from my section. And please, if you don't know how to answer, just copy whatever you remember throughout your slide, throughout your notes. That will be better rather than you copy others. Okay? So, any question related to that? Or maybe you think, oh, I'm the person. I'm afraid that I'm going to get 0.
Yeah, miss, I have a question.
Yes, why?
When we will get our marks?
Wait, let's check the update. Digital logic. Update 3 session. Oh, dah selesai tapi kena ulang. Okay, the person in charge mentioned altogether already finished 7 sections. They're going to finish until all together section 10 section, right? After that, we're going to push the marks for all of you. Okay, they're going to continue tonight after their class. So still on markings, there is one of my students yesterday called me asking why he gets 0. I said because it is like processing marking. Maybe we skip the question. Maybe we want to compare the answer because there is a problem yesterday because of the copy paste, and then because someone published the question to the website. So we are still investigating the problem also. Okay, so please stay tuned about your mark. Any other
Thanks a
question?
lot, Miss. Thanks a
Okay.
lot.
Any other question? So if you think that you are the one who did the wrong, please contact me directly. Justify why before we even call you one by one. Okay. Then your name will be mentioned later in Telegram. All section will totally know who did it. What else? Your retest for your test 2. Please make sure retest on 20 January. Whoever need to take retest, please make sure you remember the date and keep get an update through your Telegram. Okay. So, shall we continue with our module? We're going to go for our synchronized counter. If you still remember synchronized counter, it means you are having the similar and same clock. Although you have a lot of flip-flop that connected together, it is still from one source. Okay, so this is all connected to one source. That is synchronized. And unsynchronized, different clock. Okay, that is the first thing that you need to know. Last time you have 4 steps. For your unsynchronized counter, you did learn how to draw the logic symbol, you draw the timing diagram, you draw the stat table, you draw also the stat diagram, isn't it? But now under synchronized counter, last time your flow is from table to diagram. But here there is 6 steps and you need to develop the stat diagram first, then you go for the stat table. But instead of having stat table normal queue last time, you're going to have the next stat table. You can assume it's to be previous queue and also your present queue. But it is also basically similar because last time you always like talk about previous queue, right? But this one can be your present queue, and also this will be your next queue or next your output. Okay, step by step. First of all, you were given with the question. The description on general sequential circuit in the term of passive part. Maybe you were given with 2 bit. Okay, then you know, okay, there is a 2 flip-flop. If 3-bit, you know, okay, there is 3 flip-flop and so on. But of course, you still don't know about the input of this old J, K, or maybe this is D, or maybe this is a T flip-flop. It depends on what type of flip-flop that you use. After you know input and output, of course, you don't know the value yet until you finish. You need to develop the state diagram depending on what type of counter you have. Maybe you have the count up counter, positive clocks, a synchronized counter. Then you're going to have like 0, 0, 0, 1, 1, 0, 1, 1. But maybe you have a 3 bits counter, then you're going to have 0, 0, 1, 0, 1, 0, 1, 0, 0, and etc. So that is the state diagram that you need to come up. And then the next set table, the things that I mentioned, you need to have like Q, present Q, and also your next Q. After that, you need to have the transition table. What is transition table? This is your new terms. We're going to look into this. Last time I asked you to read your notes before class. Maybe some of you knew already. What is basically transition table? Sorry, I checked my notification because I need to keep update about the open day because I'm the one who need to represent School of Computing. Okay, now next is about KEMAT. Yesterday is that I guess on Friday there is a student asked me what module will be covered for your final exam. If I can say it is starting from module 7, but you still need to know your module 5. You still need to know about your module 3. You need to still know module 2, 1, etc. in terms of knowledge. K-maps, in what module? 4 or 5? I also forgot already. But you still need to apply K-maps. Logic equation, module 3. Numbering system, module 2. And your basic CAD. Also, you need to have knowledge. That's why I mentioned you can having the questions starting at module 7 and award until 9. But your knowledge will be continuous. So don't just like, okay, I already forgot already about KML. What is the KML? I forgot about how to group. So everything is related. And lastly, in your step 6, implement the counter implementation. What is this? Okay, let's go through one by one. We're going to look into the table, excitation table. How you going to do the transition table? Okay, this is your normal JK flip-flop. Okay, I draw the table for your Q 00011011. If you still remember, you must to remember this is no change, this is reset, this is set, this is toggle. Last time, if you remember, we learned how to derive the SR latch, SR flip-flop, I guess so. And I can't remember whether we derived JK flip-flop or not, but I asked you to do so. The derivation to you to get the summarize all of this. Okay, so here, there is several condition. If let's say you have the output for previous output, or maybe we can like directly assume is to be present Q. Present Q, we name it as like Qn. So over here, if we have the condition of 0, 0, you can see here, 0, 0. Sometimes our Q can be 0, previous Q, okay, or present Q will be 0. Sometimes it can be also 1. That's why you need to have 2 0 0 0 0 here. Depending on the Q, sometimes your Q, your output is 0 at that time. Sometimes it's going to be 1. So what is happen to your next Q? We do it as a symbol of Q and plus 1. What is happen next? Follow the 0 0, no change here. So you look into the no change condition. Why no change is already done? You already derived last time. So here, if at the condition of 0 0 0 0, whatever value of your present output is going to be follow, isn't it? So next, we have the condition of 0 1 0 1. If sometimes it can be 0 for your Q and also 1. So 0 0. What will happen? Reset. So not going to look into your previous output. It's going to directly put 0 0 here. Okay, next. What will happen to my 1 0 1 0 here? It will be reset. So if reset here, we're going to have 1 1. Doesn't matter what happened to your present output. Your next output will be 1 1. And lastly, toggle. If it is toggle here, where you're going to refer to your present output. If 0, it's going to be 1. If 1, it's going to be 0. You're done at this part. Any question to get these things? This is the basics thing. It is not too hard, I guess. So next, what we have here, we will get like this, similar to what I draw just now. Okay, so I'm going to stick with that like this. Alamak, tapi I punya dah padam pula. Okay, now here, how I'm going to get my, what is the name? Flip transition table. How are you going to get the transition table? Before we can get the transition table, we need to have the summarization for the scenario here to get your excitation table. Okay, let me have the conditions of Q now, present Q, and the next Q. The next Q. So if let's say my Q is 0 and then my next Q is 0, where will be a condition? If my Q is 0 and then next Q is 1, what is the JK value? Why we need to know the JK value? Because this is the things that you're going to draw. Go back to your step number 1 here. This is the thing that you need to know about the input and output, but you still don't know. It's depend on the value here later on. Okay. So next, you also have the present to be 1. And maybe the next will be 0 and then 1 and the next will be 1. Because there is 2 present and next, that's why you have 4 possibilities here. How you're going to define your value, your value of your J and K. So by referring to this table, alamak mana dia? Okay. By referring to this table, if the condition of 0, 0, where is it? You have 2. Present is 0, next state is 0. Present is 0, next state is 0. You have 2 conditions. One condition, your J equal to 0 and your K equal to 0. The second condition, you have J is 0, K equal to 1. So how you can summarize to put the value inside here to create your JK things? How you going to connect your J and K? What is the value here? Is it high? Is it low? Is it this is 1, this is 0? So let's see. J is 0, J is 0. So we can put it as a 0. But our K is 0 and it can be also 1. If you can see this condition, what we call it? X, which is we can become as 0, we can become to be as a 1. So our K now is X. We done for our 0, 0 part. Let's see the conditions of previous Q is 0, next Q is 1. So now previous Q is 0, next Q is 1. Previous Q is 0, next Q is 1. So this is the condition. So let's check what is the condition I have here. So my condition now, J is 1, K is 0, and another one, J is 1, K is 1. So I can conclude J is always 1. And my K is either it is 0 or 1. So I can become as both. So it's going to be X. So let's check what another condition I have here. 1, 0. Where is 1, 0? I have here 1, 0 and another one here. So this is condition that I need to take a look. First, J equal to 0, K equal to 1. Second, J equal to 1, K equal to 1. So I can conclude K is always 1 here. And my J is 0 or 1. It will be X. Hey. So I'm done with that. Last condition, I'm going to have 1, 1. This is 1, 1. And this is 1, 1. Check my condition. I'm going to have J equal to 0, K equal to 0. And J equal to 1. 1. K equal to 0. So my K here is fixed. and my JKX. What is the purpose of this table? This is the table that you need to remember. This morning, section 03 asked me, should I remember all the derivation? Because you're not going to do for JK only, you need to have the T flip-flop, SKD. So you need to know how the derivation and get the excitation table. But instead, you can also direct remember. I suggest you to understand how you're going to derive it to get this table. You're going to apply this table later on. For the D, T, JK, you need to remember. But later we're going to look into the D and T, okay? So go back to these things. After you have the excitation table, then you can come out with your stat diagram. So let's I check one by one what happened using this table, because this table we know already, okay? Okay, when I have the condition of 0 and 1, I have the stat 0, I have a stat 1. When I have the 0 to the 1, when I have 0 to 0, 0 to 0, you can see here, 0, I'm going to go to the 0 back. What is the conditions? The condition is, what is the condition of my JK? It's going to be 0, 0. And then I have 1, 1. Means that present state as 1, it's going to go to the next state as also 1. So it will be scenario of 0, 0 also. Next, I have here 0 to 0 again. But now my condition is 0 and 1. Okay, let it be. And then I have 1 to 0. 1, I'm going to go to 0 with the condition of 0, 1. After that, I have 0 to 1. 0 to 1, I'm going to have the conditions of 1, 0 for my J and K. And 1, 1, I have another one, is 1, 0 here. 0 to 1, 0 to 1, I have another condition, will be 1, 1. And lastly, 1 to 0, it will be 1, 0. How? Because I have 2 here, I need to have only one condition. So it's going to be 0x, 1x, X.
Doctor, the last is
Salah.
0, 1, 1, 1, right?
Where is it? Where is it?
Just now you deleted one.
Okay. 0x. And this one, 1 to 0, 1, 1. Sorry. So it will be x and 1. So this is the timing diagram that you can have for the stat diagram JK flip-flop. So again, x is, it can be 0, it can be also 1. If you find x in your K map, it will be the helper to your 1 to get a better, to get a bigger grouping. But if it doesn't help, you just ignore it to be as a 0. Okay. So you later on, I'm going to do, if I have enough time, check. We're going to do maybe tomorrow for the these constructions of D and T, but it's very easy. This morning, the section 03, they did like about 10 minutes only. Okay, so this is the summarization that you can have. You just need to remember, but it's good for you to know how to derive until you get this kind of table. So let's check example of step by step about your 6 step. So you have first, under your JK flip-flop, you given to have 2-bit synchronized counter. You don't know yet. You just know you have the flip-flop 0 and then flip-flop 1. Here will be your J1, K1, J0, K0, and here will be Q0, Q1, isn't it? And about your connection of your J and K, you still don't know. And this will be your clock, which is you already know it's connected to each other, CLK. This is the question we will find out after we finish step 6. So this is step number 1. You need to have the design of JK flip-flop. There is no input and output element at the design yet because you don't know yet, okay, what is this, what is this. We will find out after we finish. Draw the state diagram because this is the counter 2-bit. You're going to have 0, 0, 0, 1, 1, 0, 1, 1. Done. Step number 3. Step number 3, you're going to do your next state table. Next state table, you're going to include your next one. So you're going to have the present and next state. Present state, you have 2 bits. You have 2 bits, okay? This is bit 1, bit 2. You're going to have Q0, Q1, isn't it? Normally we like put A0, A1. Now we are having Q0, Q1, similar to our flip-flop here. Okay, so our present state, this is our present state. Before this, we have Q1, Q0. Present state, if 0, 0, then your next state will be 0, 1. Now here will be your present state for Q1, Q0. If this is present state 0, 1, you're going to go to the next state of 1, 0. Your next state of 1, 0 is 1, 1. Present state is 1, 1. Now you are here. Then you're going to go to next state of 0, 0. This is your things that you need to do. Step 1, step 2, step 3. This is very easy. And after that, you're going to have transition table for your previous present and also your next table. Just now you already create this. Then you need to have the transitions. Transition table is including this thing. This is your next state table. This is your next state table with the JK transition is called as altogether transition table. Okay, how are you going to get the value of JK things here? Referring back to your excitation table, you look into Q0 present, Q0 next. When you have, because you need to consider it to be 1 bit. Last time we did derive for 1 bit. This is 1 bit. When we have 2 bit, we need to follow also this one. 0 to 1. Present 0, next step is 1. Where is it? Present 0, next step is 1. My JK is 1x. So I put at 0, 0 here, 1x. Next, I have, because this is 1 bit, now I have 2 bit. Q1, Q1. Present Q1 is 0, next Q1 is 0. 0 and 0, my JK is 0x. Because this is 1, this is 1, 0x. So I repeat for the next one, which is basically similar. I have Q0 is 1, it goes to the next Q0 as 0. So I have 0, 1, 0. 1, 0, I'm going to get x1. Next, I have here the value of Q1. My Q1 now is 0 for present. My next Q1 will be 1 here. So from 0 to 1, my value of JK is 1x. I continue my Q0 here for present, my Q for next, 0 to 1, it will be 1x. Here is 1 to 1, 1 to 1 will be x0. So I continue until I can map everything here. So let me repeat. You're going to have the drawing here for step number 1 without knowing the input and output yet. Second, you're going to draw the state diagram following what is the equation needed. 2-bit now. Then you need to have the create next state table. This is a state table, but with the next step, you're going to have the next step table. By doing the next step table, you just add another JK transition. You're going to get your step number 4 transition table. How you're going to get this transition JK? By using the excitation table. Just now we derived for 1 bit FFGK. We can look into the bit by bit. First, it bit 0. Next is bit 1. Second, bit 2. Another one is bit 3, and etc. So referring to similar bit from present to next, from present to next, from present to next, from present to next. Following the similar bits, you put the value in until you get the transition table here. After your transition table, you have step number 5, which is using care map. So you need to come out this to be as an output. This is one output, this is one output, this is one output, this is one output. Because you don't know, just now I mentioned to you, you don't know the connections of this. You don't know the connection of this. You don't know the connection of your another J and K here also. So that's why you need to come up with these care map things. Okay, what is the... Okay, by using the transition table here, you just need to consider your present state. Let me take one example. First is J0. I have my Q0, Q1, 0, 1, 1, 0, 1. So here 0, 0 will be 1. 0, 1 will be 1. 1, 0, it will be X. Another one will be 1, 1, X. Okay, you can come out also with your tables like this. It doesn't matter, as I mentioned last time when you play around with your K-maps thing, it doesn't matter where you put your input, because the things when you map inside correctly, then your answer will be correct. But if you copy the input wrongly, your output also will be getting wrong. So over here you will get 1x, 1x. So here you can see the mapping is look like different, but when you group later on, then you get the similar answer. So here you can group it to be like this. For what is your answer? Like this, your J0 will be 1, similar to this also. This is the K-map things. That's why I really can't to imagine how the student come out with this grouping. We didn't have this grouping. Ini mainan apa? I already mentioned last time in the class. We cannot get this kind of group. Okay, then you will get J0 equal to 1. You map another one for this K0. Following your present state here, 0, 1, 0, 1, then you will get similar things. Then you're going to also come out with your K1 and J1. For this part, you can see you are grouping like this. You follow the value that didn't change. I asked you last time, right? So this is Q0 and then it will be Q0. This is also similar to AB. Last time, if you have this, you're going to have B, right? If your grouping at this side, if, then you will get Q0 bar because it's referring to 0. For your POS, similar to here. Then after you get like this, okay, now I have the connection now. Let me draw step number 6. FF1, FF0. Another 5 more minutes. J0, K0, J1, K1. This is my Q1, Q0. My J0 and K is similar, which is connect to 1, high. And this will be my clock. Sorry, it's ugly. I know. And J1, K1. J1, K1. Going to connect it to my Q0. So this is my connection. Let's see the beautiful way. So you can see. Then you get all 6 steps. Correct. Any question until up here? Then you're going to also have the timing diagram here. The timing diagram First, we have the positive clock for our Q. This is normal JK. 1 and 1 is going to be toggle. If you still remember. So start from 0, you're going to toggle at this positive, toggle at positive, toggle at positive, toggle at positive. Finish. After that, for your Q0, Q1, you're going to start at 0 and at this line, you're going to see this is your supposedly toggle, but at that time, Q0 is 0. JK, 0, 0, no change. Remember this one? At this one, Q0 is 0, J1 is 0, K1 is 0. What will happen? No change. That's why it's no change here. Until your next clock, your Q1 is, your Q0 is 1. The Q0 is 1. That's why you're going to do Q0 is 1. Here will be 1. Here will be 1. It's going to be toggle. So you're going to toggle. You meet another positive clock here. Your value of Q equal to 0. Then what you're going to do? No change. Until you meet another next clock. Q0 equal to 1. You're going to do toggle. Okay, any question related to your 6 step, related to your timing diagram here? I want to show another example. Before that, maybe I can, kenapa I tak boleh? I need to go into the, mana sekejap I close here first. I need to go to the postgraduate link. I lupa lah. Wait, give me a minute. Is it Telegram? Siapa yang baru nak join? Wait Why I cannot enter this link? Habis lah I. The one who need to present School of Computing. Yo. Okay, while waiting, I'm going to create the Jamboard. You need to do the D and I create my Jamboard first. Construct the table. Okay. You just need to draw the what we call it, table. What table? You need to draw it be. Okay, you need to draw this table, this kind of table, J and K condition, and then the present state, next state, and lastly, you need to meet the conditions of this. Depending on the question, if you are odd group, then you need to do the D flip-flop. If you are even group, you need to do the T flip-flop. It's very simple how to derive. Please start now through your Jamboard.
Excuse me, doctor.
Yes.
We are using which group? The lab group or the normal group?
The lab group.
Okay, doctor. Thank you.
Sekejap Mana ni?
Of that to say that we have a small international community in the campus. Being here today with us. Okay, please bear the 2 hours struggle with us today. So thank you so much.
Okay, no need to make it very like beautiful. Because this is only like 4 layer table, 0, 0, 0, 0, 0 and 1, and then you have another conditions of previous queue should be 0 or either 1, 0 or either 1. So it's like simplest. Does someone share the question again? Huh? Question is at I copy back the question here. The title is at your Jamboard.
that you looking forward is a master in cybersecurity, right?
Yep, that's correct.
That only offer at UTM-JB.
Yeah, right. So, yeah, I'm a JB. So I was just wondering if like this event is actually.
Oh, okay. Actually, we have 2 sessions, and today is
Okay, if you don't understand, please inform me because I didn't see any groups already done with the table.
So doctor, we have to walk by the steps.
Again?
Steps. We have to do the 6 steps. So
No. You just need to derive the table. Just now I derived the. Let me share the screen. Just now I derived the JK flip-flop. I want you to derive because I derived this table from this kind of table. I can get the excitation table. From this, I can get the excitation table. I want you to come out with this kind of derivation table and prove that your excitation table shows in this picture here is correct. So you need to come out with the present state, next state, the value of D here, or maybe K. Then you're going to come out with flip-flop state D or T, and then you have 0 and 1. Your condition, so you're going to have only small table like this. The value of present and
dah habis exam ke Liza?
Dah tengah kelas je
Okay.
Yang exam tu hari masa mock hari tu.
Oh, dah habis lah.
Tak tahulah lulus ke tak.
Kalau kita tunggu je, siapa tak tahu nak buka video ke. Nanti kan kita buka video takut ada orang masuk tak perasan. Jadi saya nak test ni.
Okay, nanti saya punya kelas sampai pukul 4 tau. Nanti dah habis tu nanti saya handle.
Boleh.
Okay, so your table is until here only, because you only have the conditions of your DOT, you only have the 0 or 1 only, right? So you can have the possibility to be 0 or 1 at your present state, 0 or 1 for your present state here. The next state, this is the one that you need to derive by yourself, and you come up with your excitation table for your D flip-flop or T flip-flop. Just now I show you the JK. I want you to show me the D and T. Okay, understand or not? Let me check. Group number 4 ready start. Okay, so your derivation here, how to conclude. Share also your excitation table so that I can explain. Hurry up. 5 minutes only to draw the table. No need to be perfect. Just a simple one like this also can. But I want you to put this excitation table here, group number 6. Where is others group?
Hello.
Okay, I guess some of you already done. I don't know what happened to another groups. Let me directly go to someone that already done, okay? And you can see basically maybe what I mean with the tables. Okay, now you can see here group number 2. It's better for you. Can you try to share also your excitation table? Okay, I have group number 3 here who did in the D flip-flop. Okay, D flip-flop. If you still remember under your D flip-flop on your module 7, you have the conditions of EN 0 and 1. But of course, every single thing on 0 here you need to ignore because it's going to be no change at all. And you have the D and condition of EN1, you're going to have 0 and 1 for your D. And what is your output? It's depending on your D also. If D is 0, your output will be 0. If D is 1, your output will be 1. Remember that? So by following this table, you're going to do your presence and next state. Okay, you have 0 with the conditions of present output of your Q is 0 and sometimes it's going to be 1 also. So you have 2 conditions. And what will happen is going to follow your D. 0, 0. Although your in previous or present output is 0, although your present output is 1, your next output will be 0. That's why you can conclude it to be like this. For your next Q next, your next state, your D is 0, you're going to get 0 also. So now you have the condition of 1 and your present will be 0 or 1. So the derivation is you're going to get 1. That's why you'll be coming out with 1 here. So these are showing like this. Okay. So next for this is wrong. Please double check. It is not following the present Q, but it is following. Terbalik. Sorry, I can't see this one. Okay. It's weird. You did this thing first. Okay, QQ. But it is also wrong because where is your next output, ya Allah?
No, doctor, we're still making it, like the tables.
Okay, now it's correct. It is correct. Okay. Slightly. Okay, because maybe this is your understanding. As long as you understand, you can get with the summarize D, Q, and T1, 01, 01. Okay, for the T flip-flop here, put the excitation table there. Okay, this. For the summarization, nampak bayang-bayang. Okay, here. If you still remember the T flip-flop, you have 0 and 1 also you have EN, but ignore that first. We have the Q will be no change. which is whole. And then for 1, it's going to be toggle. Okay, if it is no change, it's whole over there. It is toggle also. You need to following and refer to your previous queue, isn't it? Now we have the previous state or present state. For our present state here, the T flip-flop is 0. You're going to have also 0 and 1 condition. So what happened? If your present is 0, at your 0 part here, you're going to hold, means no change. It's going to follow your previous or present state to be the next state here. So it will be similar. While for 1, it's going to toggle. If your present is 0, it's going to be 1. If your present as 1, it's going to be 0. Then you can summarize it to be, if it is 0 here, it's going to be following your QN or your present state. No change. And then when you have 1 here, it is basically similar to this, which is toggle for your present state. So let me check number 2 here. Toggle, okay. 5. Kenapa ada 2 ni? Okay. T flip-flop. No change. Toggle. Group number 7. D flip-flop. Okay. 0, 0. Okay, correct. I don't know what is my mind is going to be like a toggle one. Okay, correct. And this supposedly 1, right? Here. And then what is this? T flip-flop, 0, copy, toggle. Correct. So finish. So I hope that you understand about this summarization table, excitation table for the flip-flop. If you already remember, then it's easy for you to do the 6th step there. Just referring here, but normally we're going to do the JK flip-flop. Let's see the next example. Just now we look into 2 bits. Just now we look into 2 bits, but now we're going to look at the 3 bits. It is only the matter of we have Q2, Q1, Q0. So first step, we're going to draw the logic diagram without the input and output. But the rest, the things
Excuse me,
we
Doctor.
can draw. Yes?
Are you presenting?
Just now I present the Jamboard also you didn't see
Jamboard got. No,
Jamboard got
Then
now.
suddenly stop.
Yes.
Okay. I cannot share. I cannot share. Okay, now can. What happened? Can you see now?
Yes, doctor.
Okay, why it suddenly stop? Okay, I repeat again. Okay, just now you look into 2-bit. So the thing is the matter for your 2-bit you have Q1, Q0. But for 3 bits you're going to have Q2, Q1, Q0. It's also similar like A2, A1, A0, B2, B1, B0. It's in terms of variables only. And first step, what you need to do, you need to draw, right? If 3 bits, you're going to have 3 flip-flop. But you don't know about your input and also your output yet in terms of the connection. This will be FF0, FF1 following the LSB to MSB. You have J0, J1, J2, K0, K1, K2, Q0, Q1, Q2. And you have the clock there. You just want to connect them all together. Then this is a step 1. Step number 2, it is a synchronized counter 3 bits. You're going to have 000, 001 until 111. This is the step diagram. Step number 3, you're going to do the next step table. The next step table, you're going to have present state and next state. Similar to the 2-bit just now we looked already. And it will be look 000. If you're present, currently you are here, your next state will be moving to here. So you're going to put 001. If you are currently at this state, your next state will be 010. Your current or present state is this. Your next state will be 011. Your current state is 011. Your next state will be 100. So following all the sequence. Don't just fill in without knowing what is basically happened. So you're done with your step number 3. Step number 4, you're going to do your transition table. From your next step table, you just add the GK transition table. Remember back what is happened to your JK with your Q N plus 1, 0, 0, 0, 1, 1, 0, 1, 1. What will happen? JK, KK, JJ. This is the things that I always remember. After that, we have here 0, 1, 1, 0. Is it correct? This thing? Help me, please. Check this one, correct or not?
Yes, doctor.
Okay, thank you. So, after we have this, we will put it everything into our transition table. Look one by one. Bit number 0 first. Bit 0, bit 0, bit 0. 0 to 1. For 0 to 1 is going to happen to this side, 1x. And then bit number 1 there. Bit number 1 here is going to be 0 to 0. 0 to 0, you'll get 0x. Another one is also similar, 0 to 0. We get 0x for K2. Next, we have Q0 plus J0 K0. It move 1 to 0. 1 to 0 will be x1. And this 0 to 1, 1x. This one is 0x. So you fill in everything following this table. You will get like this. So by getting this one, you will take one by one and draw the K-map for each output. Let's say I draw here because next slide will be getting all direct answer. I have J0. For J0, because I have 1, 2, 3, 3 input. Sorry, not at the next state. At the present state, only 1, 2, 3. I have here, let me do like Q2, Q1, Q0. Allah. Okay, I got like this. 0, 0, 0, 1, 1, 1, 1, 0. Please remember to draw the K-map how. And let me map 0, 0, 0. I get 1. 0, 0, 1. I get X. 0, 1, 0. I get 1. 0, 1, 0. I get 1. 0, 1, 1. I get X. 1, 1, 0. I get 1 here. 1, 1, 1. I get X. And another one is 1, 0, 0 is 1 and 1, 0, 1 is X. So I can draw like this. When I have all a group in one group, my G0 equal to 1. Because everything is yes. So it is 1. My J is 1. Now I want to have, let me go for a bit number 1, J1, okay? J1 here will be 0, 1, X, 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 0, 1. Please following basically slowly and map it here. So what I have here, I will have like this. So following here, this is my Q0. So my J1 equal to Q0. Done for my J1. Just now I remember J0 is 1, J1 equal to Q0. Okay, I done, okay? Now I want to check my J2. For my J2, I have here 0, 0, 0, 1, X, 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 X. So how I'm going to map it? I have this only. So I look here, this is my Q0. And at this side, what is state here? It will be Q1 dot Q1. J2 equal to Q0 dot Q1. Okay, F is, I remember this one is gate N. So I need to have gate N to connect my Q0, Q1 to get the output of my G2. So how I'm going to draw in terms of JK? You know the rest, the clock and etc. So this one, J0 is connected to 1. I get already. And then J1, I get it should be directly from my Q0. J1. And my J2 is basically Q0 dot Q1. So I have from this N here, and this is my Q1. I end with this, and this is my input. So you can try to check your K1, K2 also. Let's take a look the answer here. And this is how you map. This is the thing that I mentioned just now. Basically, your your K also will having the similar value. Any question for this 3-bit synchronized counter? Did you understand or not? Okay. Tadi I punya presentation is hilang. Now I punya voice hilang ke?
Tak doktor, okay doktor.
Okay, doctor.
Okay. Now we go to the timing diagram. After we have all these 6 steps there, after 6 steps, after wait, okay, you can see here, this is your clock. Just now you have the positive clock. All the positive clock, right? So here we will do the positive clock and do it one by one. First is your Q1, Q0. Starting from 0, your upper positive clock here is going to be toggle, because your value of your JK for the beginning of your first FF0, it is high. You see here, it is high means that JK is 1, 1. So that's why you're going to do all toggle at the positive clock. This one we do many times already. Second, for your Q1, your input now it's not 1, 1 for your J and K, but instead your J and K is Q0. That's why you need to refer for your Q0. Lama saya terpadam ni juga. So it starts from 0 and then at a positive clock here, your currently Q0 is 0. That's why your J and K is 0, 0. If it is 0, 0, what happened? You're going to no change. Remain, no change. And then at this side, your Q equal to 1. That's why you're going to toggle this part. You're going to see that your Q0 is 0. So it will 0, 0, no change. So you're going to continue. And after that, you meet another high here. Then you're going to toggle. So here there is an explanation. Goes opposite every time your Q0 is high at the positive edge of the clock 2, clock 4, clock 6, clock 8. So you can see by connecting the Q0, the J1 and K1 input of flip-flop. Because by logic things, we can see that if you didn't have any output, because your Q is 0 right here, if your Q0 equal to 0, this one is not on, or it is always 0, 0, which is no change. But it's going to on when you have the input of high. You can see here. Or you just use similar things to what I did. If Q0 equal to 0, it is no change. When you meet another positive clock there, and at this side it is 1, means that you're going to do toggle. At this side, 0, that's why you're going to no change, and then toggle at 1 here. This one is remain no change, and then toggle. So next, you have this thing Q2. Q2 referring to this value of Q0, Q1, N. Means that you have N. If Q1, Q0 is 0, Q1 is 0, you're going to get 0 here. 0, 1, you get 0. 1, 0, you get 0. 1, 1, you get 1. So the other rest things, you're going to have no change. And only when you have 1 and 1 at your Q1 and Q0, you will get toggle. So let's check. Here, no change first. At here, this will be 0, 0, no change. Here will be your value of 1, 0, no change. 0, 1, no change. 1, 1, toggle. 0, 0, no change. 1, 0, no change. 0, 1, no change. 1, 1, toggle. So here is the output. Okay, do you understand?
Yes, doctor.
Yes, doctor.
Okay, so from this, you can also come up with the 3 bits, 4 bits. Everything is totally similar from your previous one. So I'm not going to go deeper directly to your 2-bit down, counting down, because I want you to basically understand first the things here. So I want you to try to do the exercise before our class tomorrow. Design 2-bit synchronized this counter using T flip-flop and D flip-flop, and then showing all the 6 steps, and this 3-bit synchronized, 4-bit synchronized, and all this example. You have another 10 more minutes. Maybe you can try to do it together with your friend, okay? So tomorrow we're going to continue for 2-bit down synchronized until, let's recheck until cascade counter, I guess. Okay, so any other question? So if there is no more question, I need to go so because I have the postgraduate open day, I need to handle the School of Computing. Meet you again tomorrow. For those who still not yet scan, please scan now. And for the rest, please stay safe and bye-bye.
Thank you, doctor.
Thank you, doctor.
Thank
Thank you, doctor.
Thank you, doctor.
Okay.
Thank you, doctor.
Thank you, doctor.
Thank
Thank
you,
you,
doctor.
Thank you, doctor.
Doctor,
Yes?
can I know how we determine the state diagram, whether it is 0 to 01 or 01 to 00? Like it is reverse or like go directly?
Oh, the counter.
Yeah.
Normally it's going to inform you to be, just now, it shows our next will be the down, right?
Yeah, then it is like 00 to 11. So I'm a bit
Yes.
confused about it. So it will mention in the question, is it?
Yeah, supposedly it's going to mention whether it is counting up or counting down.
Okay, understand. Thank you, doctor.
Okay.